In this video, I'd like to show you a presentation about classes and some object-oriented concepts. And I call this presentation an overview of C++. You already know because many of these topics we have already covered in the last semester. So this is a general view of a first C++ program using IOStream, which allows us to use character output device, and this is the formatted output style that we normally use to display information, sending it to standard output stream. So of course you know how to make function calls. We are already familiarized with control structures such as different kind of loops, if, else, switch, and so forth. Native data types or primitive data types use these keywords. You already seen arrays and pointers and some elements of dynamic memory allocation using the new operator. Stream input output library, generally that you can get access to by including this library header, gives us access to character output device, character input device, and standard character error device, which should be used to report errors. The end of line manipulator flushes the character output, allowing it to display the information that was sent to the output as soon as possible. The output and input operators used with cout and syn respectively produce results of formatted output and formatted input. Keyword enum creates an enumeration of a set of constants that have specific names. So for example, if we want to build a card game in our software project, we can create a suit, define clubs, diamonds, hearts, and spades as constants. They will be automatically assigned numbers 0, 1, 2, 3. And then this is an example of creating an object of type S, and then we can assign specific values to this object, and sometimes you can use specific integers and cast them as a suit type. Of course, number 1 right here would correspond to the diamond constant, and this primarily allows us to use these types of variables so that we do not make errors by assigning random integer values to them. So this would restrict us to use just specific constants. This here is another example of enumeration for some print flags, but we could actually create an anonymous enumeration and remove this name. This way we just have access to these constants in our scope. You can see that automatically these variables are assigned 0, 1, 2, 3, and so forth, set of constants, but you can choose your own specific constants. If you by mistake assign duplicate value, say 1 to both of them, compiler will catch this as an error and will force you to provide unique values to your enumerations. If your last constant on this list is set to a specific value, the next value could be automatically assigned without specific initializer the next subsequent integer. So this will be 5, 6, 7, and so forth. So besides, so you can mix automatic assignment of constant values with your own specific assignment. User-defined types are produced by keyword struct and class, and of course you can recognize these structures very easily. Struct makes everything public, and generally speaking, the guideline is that when you have a struct that uses only public data members, that's okay, but as soon as you start adding member functions to your classes, to your structures rather, you should be trying to use a class. In a class, the default access type is private, so if you'd like to make X and Y public inside your class, you have to explicitly declare it a public. And of course, this is an example of declaring a point structure and accessing its parameters. So using existing classes means including some sort of library headers or your own headers where the classes are declared, and just start declaring objects of whatever types are available. So here's an example of standard library string, which I declare first that I'm using it, and now I can just declare its type. I mean, use its type to declare a variable, assign a value to it, and start using it in the rest of this program. So of course, classes support member variables and member functions. So here we have a member function example that is added to the point class that makes adjustments to the current position of the point. This coordinate X and Y gets modified. And of course, we need to use the semicolon because this compiler, when it sees class point, recognizes, it has to recognize it as a class declaration. And you know that we normally use declarations. In declarations, we normally use semicolons at the end of them. So this also applies to declarations of classes like this. And just don't forget the semicolon. And this is an example of using this point class right here to create an object and calling a member function like this to make some adjustments to the initial coordinates. Before you design your own classes, it's advisable that you study existing classes, and C++ standard library is a perfect source of combination of all sorts of classes that you can study and learn from. And later you can design your own classes, but always keep in mind a client perspective to keep your classes usable. Just a couple of reminders about C and C++ comments. So the comments, there are two kinds of comments. There's a single line comment and multi-line comment. However, just remember that you should never mix those. The strange mixing of the syntax here may produce strange compiler errors, and some compilers will give you a warning when the comments are mixed.